IMAM-DS. In this session, we'll be talking about fundamentals of cavity preparation. Before we go into the cavity preparation proper, we have to understand some of the terminology associated with the same. So we'll be starting with understanding what is simple, compound and complex cavity preparation. When we say simple cavity is the one that involves only one tooth surface, as we can see in this diagram over here, while a compound cavity is the one that involves two surfaces, as we can notice in here. So the surfaces involved are the occlusal and the proximal. If the cavity involves one more surface, possibly if there is an extension on the buccal or lingual surface over here, this will be called as complex cavity. When the tooth is prepared for the receiving of any restoration, these prepared surfaces, they have these walls, and these walls can be classified in the various ways. So we have a classification over here wherein the tooth walls can be classified into the internal walls and the external walls. Internal walls are the prepared surfaces that do not extend to the external tooth surface. So we can notice over here, the surfaces, this wall and this wall, which are not extending to the external tooth surfaces, are called as the internal wall. But if you notice these ones, these are the walls that are touching the external tooth surface. So these are called as external walls or outside walls. Now the internal walls further can be the axial walls and the pulpal walls. The axial wall is an internal wall that is parallel with the long axis of the tooth. So we notice here this was the internal wall and this is the long axis of the tooth. So this is an internal wall that is parallel with the long axis of the tooth. So this is called as the axial wall. Now we do not consider this wall as an axial wall because although it is parallel to the long axis, but it is not an internal wall, it is an external wall. For a wall to be called as axial wall, it need to satisfy two scenarios. It should be internal and it should be parallel with the long axis. Now there's one scenario wherein this axial wall can be converted to the external wall. Now in a case wherein we have a deep cavity and we tend to remove this axial wall, remove the pulp of this particular tooth, in such a scenario the axial wall will be shifted here and then it will become an external wall which is now continuous with the external tooth surface, and it will take the name of the surface of the tooth towards which it is placed. For example, if this is the mesial surface and this is the distal surface, this external wall will be called as the distal wall. So in this diagram we can notice the internal walls, that is the pulpal wall, this one is the pulpal wall and this is the axial wall, and here we can see the external walls that are touching the exterior of the tooth surface. Now as we've already seen, the pulpal wall is the internal wall that is both perpendicular to the long axis of the tooth and it is occlusal to the pulp. Now if this is the long axis of the tooth, this particular wall is the pulpal wall because it is perpendicular to the long axis of the tooth and it is the internal wall, not communicating with the exterior of the tooth surface. Now in case there is a deep cavity and the pulp is removed, in that particular case we tend to remove this tooth structure and this wall no longer lies occlusal to the pulp and it becomes a subpulpal wall. This is an important MCQ. So in case the pulp is removed, the pulpal wall becomes the subpulpal wall, while we already saw that the axial wall becomes the external wall. Now we have seen the two types of the internal wall, that is the axial wall and the pulpal wall. Next we come on to the external wall. The external wall is a prepared or a cut surface that extends to the external of the tooth surface, as we have already seen over here. So now when we name these external walls will be named according to the side to which they are present. Now for example, if this is our tooth and this side is the lingual side, and here we have the mesial, and this side we have the distal, and here we have the buccal side. In this particular scenario, this wall will be called as the mesial wall. This particular wall will be called as the lingual. Here this will be called as the buccal, and this which is facing on the gingival side will be called as the gingival wall. So you can say gingival wall is a variety of the external wall. In this diagram we can see this is the external wall which is touching onto the exterior of the tooth surface. Then we have a term that is called as the floor or seat. So in a prepared tooth surface, a floor or a seat is the wall that is flat and perpendicular to the occlusal forces. So this is the tooth and we have the forces that will be directed on this side. So the walls which are able to resist, so the pulpal wall and the gingival wall which are actually taking up the occlusal forces, are called the floor or seat. So we can notice in here this is the direction of the occlusal forces, and these are the walls which are perpendicular to the occlusal forces and can bear the occlusal forces. So these are called as floor or seat. Then based on whether a particular wall is made up of enamel or dentine, it is called as enamel wall or dentine wall. So to understand this, let us have a diagram of the tooth over here. This is the enamel, this is the DJ, and herein we have dentine. So if we prepare a cavity, for example, if this is the cavity, this particular wall is the external wall of the cavity. Now if we notice, this external wall of the cavity is partly in enamel and partly in dentine. The part of the wall that is in enamel is called as the enamel wall, and the part of the wall that is in dentine is called as the dentinal wall. So as simple as that. Now let's move on to understand two more simple terms, that is the line angle and the point angle. So line angle is the junction of two surfaces that is along a definite line. So we can see if we take these two surfaces, they join with each other at a particular line, and this is line angle. But if we consider three surfaces, these three surfaces will contact each other at a particular point, and this will make a point angle. So this is line angle and point angles. Now as we know line angles, now let's classify these line angles based on their direction. So if we have a line angle whose apex points into the tooth, for example, if we have the two surfaces like this, and the apex is pointing inside the tooth, then it is the internal line angle. We can have a very simple example. We have a cavity over here like this. Okay, these two surfaces are contacting each other at this particular line angle, and this line angle is directed inside the tooth. So this is an internal line angle. But if one particular line angle is directed outside, for example, if we have this cavity, this particular line angle is actually pointing away from the tooth, and this is called as the external line angle. So that is internal line angle and the external line angle. But whenever we are considering line angle, we do not talk about the junction of the inside of the cavity and the unprepared surface of the tooth, because that particular junction is not called as line angle, but that has a specific name, that is the cavo surface angle. This point is important because when we are counting the line angles and point angles, we do not count cavo surface angles. Now whenever we have an external wall that contacts the external surface, here we have a margin of the enamel formed. Now this margin of the enamel has to be strong, and for it to be strong, it needs to have two significant features. It should be formed by full length enamel rods whose inner side are resting on the sound dentine, and On the preparation side, there should be shorter rods whose outer ends although have been cut, but the inner end are still on the sound dentine. So we don't want any rods whose inner end are damaged for us to make a strong enamel margin. Let's see diagrammatically, we can appreciate here. So this is the strong enamel wall wherein we have the whole rods of enamel, inner side resting on the dentine and outer side intact, and on the prepared tooth surface side they are supported by shorter rods. Again, in this shorter rods, inner side is still resting on the dentine, only the outer end could be cut. So we cannot have a scenario wherein the cavity preparation is something like this, because if the cavity preparation is something like this, what will happen is we leave these rods with their inner ends cut and unsupported. So these rods will be very weak and brittle and they will fracture off. So we cannot have the inner ends of the enamel rods cut. With this basic information, next we will move on to the cavity preparation.